Teams often wonder what they could accomplish if only they had more hands on deck, more people on the team with the right skills who would be available at the right time when you needed them. The bottleneck analysis in Viz helps prove out some of these ideas by pointing to areas that slow down flow due to either insufficient capacity of people with the right skill set, expertise, and domain knowledge. The more we scale, the more we need specialized people. And it's this growing division of labor in IT that results in the need for more expertise. So let's begin with an example from the world of traffic flow. So imagine a two-lane road merging onto a one-lane bridge. Cars are forced to merge from two lanes into one lane to cross the bridge. And say it takes a car about 30 seconds to cross the bridge, and its length accommodates 6 cars. If you created a workflow to describe the drive, you would include 2 workflow states for this portion of the road: a wait state for ready to cross bridge, and an active state for crossing the bridge. The crossing the bridge state would never have more than 6 concurrent cars in it, and it would only take about 30 seconds for each car to cross the bridge in what otherwise might be, say, a 45-minute journey. Metrics on the crossing the bridge state might look pretty innocuous, only 6 concurrent work items and a duration of 30 seconds. However, what will point to this bridge as a bottleneck is the backup of cars in the prior state, ready to cross the bridge. This preceding wait state will have a higher count of cars, which will likely spend much longer than 30 seconds in it as they wait for their turn to cross the bridge. The high count and the long wait times in this wait state point to a bottleneck in the active state downstream crossing the bridge.
So now let's apply this to the world of software. In a product value stream, you might see this type of problem occurring when there's a limit on the amount of concurrent work that can be taken on during one of your active states, the equivalent of the one-lane bridge. For example, an engineering team has capacity to work on 3 features at a time, but the support team only has the capacity to troubleshoot 3 issues at a time. How will you see this in Viz? When there's a resource or expertise constraint slowing down flow, the Viz bottleneck analysis will show high artifact counts and state durations in the preceding wait state. Your understanding of the sequence of activities in your workflow will help you see that this is merely a symptom of a constrained skill set or level of expertise in the active state that follows. So how do you solve it? Well, let's go back to the bridge. There's no point investing in increasing traffic flow before the bridge. It would help cars get to the bridge faster, but they're going to wait longer there to cross the bridge. The solution here would be add more lanes to the bridge to increase throughput. In software delivery, the solution to an expertise constraint is to ensure the right skills are available at the right time. Be sure to identify the precise set of skills in short supply. Hiring is one solution that might be appropriate, but you may also want to consider training or cross-training existing team members. The number of artifacts in the wait state can help you estimate how many more trained specialists you may need.
So let's summarize here. When a lack of resources or expertise results in long wait times and work gets stuck, it'll manifest in high artifact counts and state durations that sit in the wait state, preceding the constrained active state. To solve it, consider adding more skilled team members to the constrained active state.